All right, so chapter 3, we're going to be talking about graphing lines, equations of lines in two variables, so an x and a y. And so these first couple sections are a little shorter compared to the others, but there is a little bit of writing, so we want to get some definitions out. So the first definition is for a line graph. And so a line graph shows changes or trends over time. And so think of your regular, if time is down here, and then this is some quantity up here. If we have a line going like this, that means that over time, the quantity is going up. So we're going to be looking at graphs like this. And then this first example here is based on a figure in the book. So I'm going to go ahead and write down both of the questions first, and then I'll switch over to the book. And if you wanted to pull this up on your book, you can. So this is figure 1. And it's a line graph on page 214 in the book. So just on that e-text off to the side on MyMathLab. And so the first question is to estimate the average price of a gallon of regular unleaded gas in 2009. And then I'll go ahead and write down the second question, and we'll switch over to the book about how much did the average price of a gallon of gas increase between 2009 and 2012. And since these ones say estimate and about, there's going to be more than one correct answer. And if you see questions like this on the homework, there's usually a range of values that they accept. So as long as you're close, you'll be fine. So let me go ahead and switch over to the textbook. So we have the textbook here, and this is the graph that we're going to be looking at. So it's figure 1. So if you look, we have our line graph here, and then we have the years down at the bottom, 2008 to 2015. And then the price starts down here at 0. They use these slashes to show that there's a break. Not all of this represents the same amount because you want an equal amount between all of them. Goes up to 220 and then goes up by 20 cents from there. So our first question was estimate the average price of a gallon of regular unleaded gas in 2009. Well, if we take a look at 2008, 2008 is right here, so we're going to go to 2008, go up to the price, and it's a little bit over 3.2, not quite halfway, so maybe 3.25. And so if we look at 2009, that was just so you can kind of see what we're doing. Try to find it for 2009. And so 2009, you should start at the bottom and go up right here where our point is. That's roughly right there, a little bit over the 2.3 mark, so maybe 2.35. So I'm going to go ahead and say 2.35 for that first one. And then we'll mark it like that. Number 2 said about how much did the average price of a gallon of gas increase between 2009 and 2012? Well, we said that it was $2.35, in 2009. In 2012, if we follow this up, it's roughly right here. And I'm going to say, since this is about 3.7, that's probably 3.65. And so to find how much it increased, we want to go ahead and subtract those. And so the increase for number 2 is going to be 1.35. And make sure you're putting dollar signs on those, because those do represent prices in dollars per gallon. So technically we should have $1.35 per gallon All right, so we had 235 and 135. Let me switch back over. Cool, it's still there. So we had 235 and 135. Perfect. All right, so that's the first little part. Reading graphs usually isn't too bad. Now let's talk about linear equations in 2 variables. We've been looking at a lot of linear equations in 1 variable because we can solve those. We can graph linear equations in 2 variables. My laptop around here, there we go. All right, so if you remember before, our equation was ax plus b equals c. Well, now we have 2 variables, so it's ax plus by equals c. And again, we're going to say that a, b, and c are real numbers. And then a and b cannot both be 0. So we'll see some cases where you can graph it where you might have 0 for 1, but we can't have both a and b being 0, because then we wouldn't have an x and a y, we would just have a number c. So we'll be graphing stuff like 3x plus 4y equals 9. So this is in standard form. We have the x's and the y's on the left, constant on the right. X minus y equals 0. This is also a linear equation in 2 variables. And the solution to an equation where you have an x and a y, we need a solution that has an x and a y in it. And so the solution is an ordered pair. And so remember, an ordered pair is that point x, y, where you have an x coordinate and a y coordinate. And so let's go ahead and first figure out, or take a look at how to figure out whether or not a point is a solution to an equation. So, examples. Determine whether each point is a solution to the equation 5x plus 2y equals 20. So we're going to do this for a couple of points. This first one here is the point 0, 10. So we want to know if this is a solution to this equation that we're given. And before we took a look at some 1 variable equations where we needed to figure out if a specific number was a solution. And so we wanted to plug that in, make sure that the left side equals the right side. And if it does, it's a solution. Same thing with this, except now we're plugging in 2 things. We have our x coordinate and our y coordinate. So we're going to replace our x with 0, so 5 times 0, plus 2 times y, which is 10, equals 20. Don't move things around, just simplify both sides. So the left side, 5 times 0 is 0. 2 times 10 is 20, equals 20. And 0 plus 20 is 20. And so this one is a solution. So you're just going to say yes, or you can say it is a solution, but make sure you actually write out the answer. And it'll be this way on the homework and exams anyway, where it'll have you click yes or no. That part's really important because just showing this, it does show it, but it doesn't answer the question. All right, so big things here. Plug in, and then check that the left side equals the right side. Go ahead and try another one. Let's check the point 2, -5. So if you want to pause, plug this in, and then make sure you got it right. I'd suggest doing that. But let's go ahead and get started. So again, we have an X and a Y. Remember, X always goes first. The way you can remember that is it's alphabetical order. X comes before Y. Now let's plug X and Y in. So 5 times X, so I have 5 times 2, plus 2 times Y, so 2 times -5, equals 20. Now let's multiply. 5 times 2 is 10, plus 2 times -5 is -10, equals 20. 10 plus -10 is 0. So since 0 does not equal 20, then no, it is not a solution to our equation. All right, so that's if we're given an ordered pair and we want to see if it's a solution. Another type of question we could be asked is, given part of a point, what is the other coordinate? So if we're given the X or the Y, what is the missing part? So we want to complete each ordered pair for Y equals 2X minus 9. And this is something we'll do when we first get into graphing before we learn the shortcuts. We're going to pick an X or Y and then find the missing part so that we can graph that point. So number 1, we're given the point 5, comma, blank. So think about what we're given and what we're looking for. We're given X, looking for Y. So we can plug in what we're given again. So let's plug in 5. And we don't know what Y is, so I'm going to leave Y alone. And then X is 5, so 2 times 5, and then minus 9. And then we can simplify to find what Y is. So Y is equal to 2 times 5, which is 10, minus 9. So Y is equal to 1. And so our ordered pair here has a missing coordinate of 1. All right, let's go ahead and try one more. For this one, we're gonna be given the other part. So we're given blank, comma 7. So we're given Y, looking for X. Now let's go ahead and plug in what we know. So let's plug in 7 for Y. Don't know what X is, so the right side is gonna stay as 2X minus 9. This is a linear equation in one variable now, so we can solve this. Because all the X's are on the right already, I'm not going to move them over to the left. I'm going to add the 9 to the left. So we get 16 equals 2X. Those are gone. Divide both sides by 2. 16 divided by 2 is 8. And that's what our X is. And let's say you wanted to check your answers after you were done with these. All you need to do is take this point, plug it into our equation just like we did in these examples up above, and then you should get a true statement. All right, so now this next question is just a slightly different way of asking the one that we just looked at. And I do want to show you guys two of these because one of them is kind of a special case. So we want to complete the table of values. So we're given the equation 2x minus 3y equals 12. And we're given this partially completed table. So x is on the left, y is on the right. 0 for x, we don't know y. 0 for y, we don't know x. 3 for x, and then -3 for y. So we have 4 missing coordinates here. So we want to go ahead and figure them out. We have to plug these in separately. So let's go ahead and start off with x equals 0. So we have 2 times 0 minus 3y, we don't know, equals 12. Plugging in zeros is super nice because 2 times 0 is 0. And 0 doesn't change anything. So 0 minus 3 is still minus 3y or -3y. So anytime you have this, it just kind of disappears. Equals 12. Divide both sides by -3. And we get y equals -4. So that's our first missing part of the table. Now, if you can, I would pause, figure out what these three are, and then fast forward to where I'm done finding them. Double check your answers. If you got them, you're good. If not, watch my work. But I'm going to go ahead and do the next point here. So we're plugging in 0 for y. So 2x minus 3 times 0 equals 12. Simplify, so 2x minus 0 equals 12. 2x minus 0 is still 0, or sorry, still 2x equals 12. Divide by 2, and we get x equals 6. Our third one here, we're plugging in 3 for x. So 2 times 3 minus 3y, we don't know, equals 12. Now this one isn't a 0, so we do actually have to multiply this out and move it over. So 2 times 3 is 6, minus 3y equals 12. Six and 3y are not like terms, so we can't combine. Let's move the 6 over to the right by subtracting it. So we get -3y equals 6, and then divide both sides by -3. So then we get y equals -2. And that's our third number. And our final number, -3 for y. So 2x minus 3 times -3 equals 12. So simplify, we have 2x minus 3 times -3 is -9. The other way you could have done this was -3 times -3 is +9, and it would be a +9. But I'm just going to add the opposite and then rewrite it. So this is 2x plus 9. So you never really want to leave it as minus and negative in an equation when you're trying to solve, just because it makes it kind of hard. You're like, do I add? Do I subtract 9? Writing it like this is a lot clearer with what you have to do. So we need to subtract 9. So let's go ahead and simplify the right. So we get 3 and divide both sides by 2. And so we get x equals 3 over 2. This is perfectly fine. I'm actually going to write this as 1.5, just because when we start graphing, it's not as clear where 3 over 2 is on a number line. 1.5, we can see, is right between 1 and 2. So when you can, put it into a mixed number, but again, either one is acceptable. Oops. There we go, 1.5. All right. So one more of these, and this one's this special case one, and it looks tricky, but it's actually the easiest one out of these two. So this one, we're given the equation x equals -1. So even though we don't see a y here, there's technically a plus 0y. And it's still going to be a line, and we'll see what they look like a little bit more later. But for now, just know that x equals -1 is the equation of a line. And so we're given the chart -4 for y, 0 for y. And then our last point here is 2, and then -1 for x. All right, so let's see what this equation means. So this is telling us that x equals -1. So if I put a 2 here, and we think about plugging that into our equation up here, 2 equals -1 is not a true statement. So we can't put a 2 here. The only things that will work is stuff that satisfies this equation. So some number equals -1, well, the only number that equals -1 is -1. And so the other way of thinking about this is saying x always equals -1, which means no matter what y is, our x is always -1. And so that's what our two missing numbers here are. And you'll see a similar kind of thing with y. So if it was y equals -1, all of these y values would be -1. So those ones are actually really nice to fill in. You don't have to do any simplifying. All right, so then the last part of this section is just introducing the rectangular coordinate system, which should be something you all have seen before, or at least vaguely remember. You probably just don't remember the name, but the rectangular coordinate system is just the XY plane. So the horizontal axis is the x-axis. The vertical axis is the y-axis. Couple of important points. This point where they both meet is the origin. It's the point 0, 0. And then it's broken into 4 what we call quadrants. And so the top right is quadrant 1, and we use Roman numerals to indicate these. And then after that, I'll just use Q. So to the left, it's Q2, quadrant 2. Below that is quadrant 3. And to the right of that is quadrant 4. And so the way you can remember which one's 1, 2, 3, and 4 is I just remembered that it's in the shape of a C. So if you start in the top right, you're going to make a, whoops, I wanted that to be red. You're going to make a C shape. Oh boy, I just erased every single thing. Let me go ahead and undo that. All right, this is what I was trying to do. So this should be, think of this like in a C shape. And that's how you can remember the order of the 1, 2, 3, and 4 quadrants. All right, so now this last part here, we're gonna go ahead and plot some points and then figure out which quadrants they're in. So it might look a little bit messy on here just because I don't have graph paper on here and I don't think there's any way of putting it in. So for this one, we want to plot the given points. And again, if you remember plotting points, I would pause, plot them, and make sure that you know how to do them. If not, start with me and then pause once you get the hang of it. We're going to go A through D, and then E through H. Oops. E, F, G, H. And so point A is going to be 3, 5. B is negative 4.50. And then 6, negative 2, 0, 0, negative 2, 6, negative 5, negative 2, 0, negative 6, and finally negative 3, negative 5 halves. All right, so I'm going to go ahead and set up the graph right up here. And so what I'm going to do, we have our x-axis and our y-axis. I'm going to go ahead and put tick marks here. I'm just going to see how far out we go. So it looks like our largest number is 6. So I'll just go 6 in each direction. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so remember, when you're labeling these, if it's to the right on the x-axis is positive, to the left on the x-axis is negative, so we have 6 and negative 6. Up on the y-axis is positive, down on the y-axis is negative. And so when we're looking at these points here, let's look at 3, 5 together. The x tells you left and right, and the y tells you up and down. And so one really nice way of explaining this, just so you don't switch them, is explaining it like you're walking to an elevator. So you walk across the floor first to get to it, and then it takes you up or down. So this first one tells you to go 3 to the right, and then this 5 tells you to go 5 up. So we're going to start at the origin and go 3 to the right and 5 up. And I'm going to label this A, just so we know which one's which. All right, so now let's try part B, negative 4.50. So again, we're going to start at the origin, and now we're going 4.5 to the left. So 1, 2, 3, 4 and a half. So we're right in the middle. And then up or down 0. So we're actually going to be right here. Point C, we're going 6 to the right, and then negative 2, so 2 down. This is point C. D is 0, 0, so that's left or right 0, up or down 0. That's our origin. E is negative 2, 6, so left 2, up 6, left 2, up 6. F is negative 5, negative 2, left 5, down 2, left 1, 2, 3, 4, 5, down 1, 2. That is point F. Point G is 0, negative 6. So left or right 0, and then down 6. So we're on the y-axis. That's G. And then H is negative 3, negative 5 halves. So left 3, but then negative 5 halves. That one's not as easy to tell where it is, so I'm going to change it to negative 2 1/2. So we're going to go left 3, down 2.5. So left 1, 2, 3, down 1, 2, and roughly 1/2. So this is H. All right, so the last part of this question, so all of this here is for this question. We want to know which points are in which quadrants. So we're going to have the option of quadrant 1, quadrant 2, quadrant 3, quadrant 4, and then no quadrants, because there are some that are on an axis, which is not actually part of a quadrant. So see if you can figure those out. So if we look at quadrant 1, there's only one point in quadrant 1, that's the top right. So that's A. Quadrant 2 is only point E. Down to quadrant C, we have F and H. And over to quadrant 4, we just have point C. And so we only have 5 points here, so the other 3 have to be in no quadrant. They're on an axis. So B is on the x-axis, G is on the y-axis, and then D is on both. It's the origin. So we have A, B, C, D, E, F, G, H. Perfect, we have all of them. All right, so just an introduction into graphing and what our linear equations are going to look like. Next section, we'll actually get started with graphing linear equations. And we're going to start off with kind of the slower method of graphing, and then we'll learn the shortcut in one of the last couple sections of chapter 3.